Good afternoon, everyone. Am I audible?
Yes, ma'am.
Yes, ma'am.
So let us start with the thing whatever we have seen in the last lecture, starting with the paper name, that is differential geometry. So what we are going to study in the differential geometry, we are going to study the curve and surfaces. Rather, we can say the smooth curve and surfaces with the help of a calculus. Okay. So with the help of differential calculus, we are going to study the curve and surfaces. Rather, we are going to study their local properties. What do you mean by local properties? At every point of the curve, we can find out its speed, we can find out its acceleration, then we will find out binormal vector, then we'll find out torsion. Okay, whatever the things are related to that curve, we are going to find out here in the second chapter, where you are going to study the Freinet apparatus. And in the Freinet apparatus, we have a unit speed as well as arbitrary speed. And after that, we have seen the definition of a tangent vector. Okay, again I told you you should not confuse this with the slope of a tangent. This is simply a tangent vector. Okay, it starts at P and ends at P plus V, and here it is written as V suffixed to the P. As it is a tangent vector, so that's why we are using a small v notation. Okay, and we have seen some of the properties that when they are equal, then are parallel, then we are having intersecting, right? And after that, we have seen the definition of a tangent space. What is a tangent space? Collection of all the tangent vector at a point P. Okay, P को consider करके जितने भी tangent vector आप find out कर सकते हो. So that is called a TP of E3. T is a point in E3. T is a notation for tangent. So at every point P of the E3 space, we can find out the tangent space. And why it is called a space? The name space is given. Why? Because it satisfies the two with the help of two vector addition and scalar multiplication. It satisfies all the 8 properties of the vector space, and hence it is called a tangent space. Any doubt up to this one?
No, ma'am.
Yes, any student, if you want to ask any question, you can ask. Okay, if you're not having doubt, let us go for the next one, that is a definition of a vector field. Okay, just now we have seen the definition of a tangent vector. So what is a vector field? A vector field V on E3 is a collection of vector field V on E3 is a collection of all the tangent vector ones at each point of E3 space. Okay, so vector field V on E3 is a function that assigns to each point P of E3 space a tangent vector VP, a tangent vector VP. Okay, now this VP is somewhat different. Initially we have seen a small v suffixed to the P. This is arbitrary one, but here we are going to see a tangent vector related to this a vector field. Okay, एक vector field में infinite number of tangent vectors हो सकते हैं, right? So this is related to your vector field, so that's why we have some different notation. V of P, small v of P. Okay, to E3 at a point P. So at every point P of a E3 space, thus in short we can say it is a collection of all the big collection of a tangent vector once at every point P of a E3 space. It is a collection of all the tangent vectors once at every point of E3 space. Okay, So in short, let me show you in the diagram itself. So what you have to do, for every point P of a E3 space, you have to draw one tangent vector. Okay, whatever may be the direction, because we are not specified with the direction. At every point P of the E3 space, we have to find out one tangent vector. And it is denoted by the notation V of P, since we are in the vector field. As a point P changes, there will be change in a vector. और यहाँ पे क्या था, in general tangent vector ना. Here it is in general tangent vector. You can take this P in anywhere, and P plus V is also given. Then you can find out VP. But here in the vector field, what is a vector field? It is a function on E3 space in such a way that at every point P of a E3 space, there exists one tangent vector. Okay. And now here this tangent vector is denoted by the notation V of P, small v of small p. And initially we have small v suffixed to the P. Okay. Why I am explaining these notations in detail? So that you will have a very familiar idea with this notation, because whenever I am writing, you might be thinking that it is capital V and all. Okay. So actually मेरा writing उतना अच्छा नहीं है, इसलिए मैं इतना specify कर रही हूँ. Okay. So V of P, the small v of P is a vector or tangent vector in a vector field, and this one simply it will be a tangent vector which we have defined earlier one. So in short, you can say it is a collection of all the tangent vector once at every point of a E3 space. So you can see here, this is what your E3 space. At every point, you can find out a one tangent vector. Okay. Are you getting me the definition of a vector field?
Yes, ma'am.
Yes, ma'am.
Okay, so what is a vector field? It is simply a collection of all the tangent vector once at every point of a E3 space. But don't write this as a definition. Actually, definition is what? It is a function in such a way that this function is defined on a E3 space. And what is a codomain? TP of E3. Because we are saying that at every point P, we can find out a one tangent vector. So in the very similar way, at every point we can find out a one tangent space. So simply instead of saying tangent vector, we have collected there and we have written this as a vector field V. Now here you have to write down it the capital letters. Okay. Tangent vector रहा तो आपको small letters में लिखना है और vector field है तो capital letters में. Okay, so it is a function defined on E3 space to union TP of a E3. Why we are writing union TP of E3? Because at every point of a E3 space, we can find out one tangent vector. Okay. Now let us go for the one spatial vector field. The first one, which before going to that spatial one, first I will write down one example of this vector field. Is a gravitational field, magnetic field. Okay, so what is a gravitational field? As we are living on Earth, then you can observe that if you are going to put anything on this Earth, okay, अगर आप कोई चीज हवा में छोड़ते हो, right? You put any object in a air, so what will happen? It will come back to the ground, correct?
Yes, ma'am.
So this is what a vector field, because what is, but here the direction is specified. What is a direction? A direction V is specified, that will it is having only downward direction. Anything if you are going to put on a earth in air, that object is definitely going in the downward direction. But no doubt it must be in the atmospheric pressure, right? हमारा जो अर्थ है उसके आउटसाइड में एक लेयर होता है ना. Actually, three layers are there: ozone layer, troposphere, ionosphere. Then all these, with the help of that, we should have in a atmospheric pressure. जहाँ पे atmospheric pressure या gravitational field work करता है वहीं पे जा सकते हैं, right? Otherwise, we know that the astronauts go to the space station, because actually in the space, NASA has developed his own space station. so that we can stand there. जैसा हमारा स्टेशन होता है वैसे नासा का भी एक स्पेस स्टेशन है. So all the scientists, all the astronauts go here whenever they want to have a research. And suppose we go to the moon, so वहाँ पे भी कोई atmosphere नहीं होता है, right? So that's why they can't communicate with each other, because if air is present there, pressure is there, atmosphere is there, then only we whatever I am saying, it will be hearable by the person which is with me. Okay, so astronauts, those who go on the space, or they go on the moon, so they are having their own devices. जो उनका एक apparatus होता है, या फिर जो वो पहन के जाते हैं एस्ट्रोनॉट सूट, उस सूट में एक डिवाइसेस कनेक्ट होते हैं जहाँ पे वो उस डिवाइस में बात करते हैं. सो उनका जो साथी होता है, राइट, उसको वो आवाज क्लियरली सुनाई देता है, जस्ट लाइक अ वॉकी टॉकी, राइट, because there is no atmosphere there, so the sound cannot travel, right? So here also we are within this atmosphere itself. If you are going to put any object, it will go in the downward direction, so that at every point P, if we are going to put one object, it will go in the downward direction. So this is what a spatial type, that is a gravitational vector field. And next one is a magnetic field. Suppose you put one magnet here with some north and south pole. So suppose I have put some pins, so all the pins are going to this direction. Okay, वो magnet की तरफ attract होते हैं ना. So they are having different point of application, but their vector part is same. That means all the pins are going in the direction of that magnet. जहाँ पे आपने magnet रखा है, within that area only, right? Just like in the gravitational field. अगर आप ग्रेविटी के बाहर चले जाओगे तो आपके ऊपर कोई ग्रेविटी का इफेक्ट नहीं होगा, बिकॉज देयर इज नो एटमॉस्फेयर, नथिंग इज देयर. रादर यू, अगर आप कुछ बोलते हो तो भी आपके साथी को नहीं सुनाई देगा. बट हियर इन द मैग्नेटिक फील्ड ऑल्सो यू कैन ऑब्जर्व दिस. इसका एक स्पेसिफाइड एरिया होता है ना. अगर आप मैग्नेट यहाँ पे रख रहे हो और 10 मीटर दूर से आप एक्सेप्ट कर रहे हो कि ये पिन यहाँ पे जाए, सो दैट इज नॉट पॉसिबल. Which is having some specified area. Within that area itself, if you are going to put a pin, then it will attract to your magnet. Correct? Have you observed this?
Yes, ma'am.
Yes, ma'am.
Okay, physics मध्ये experiment केला असेल ना कुठेतरी magnet वगैरे. Even in the home also we are having a magnet sometime in the. So what we have to do, we have to just put up a pin, so you can observe that the directions are same. That means where you are having the magnet, they go in the same direction, but their points of application are different. And rather we can say that directions may be different, because sometimes they attract here also. Okay, direction here and here. So combinedly we can say that it has some vector field is created. Okay, so that's why it is called a magnetic field and gravitational field. Are you getting me what I told you?
Yes, ma'am.
Okay. So these are the example of a vector field. Now let us go for the specific one, in which I am going to say that suppose instead of having the vector field like this, how we define the vector field? It is collection of all the tangent vector ones at every point P of a E3 space. At every point P of a E3 space, if I am having one tangent vector, so this is a vector field capital V. And how it is defined? It is defined from E3 to union TP of a E3. Correct? For every point P, we have to find out one tangent vector. But if suppose I am saying that all the tangent vectors are going in the x direction. Okay, suppose the direction x is y and z, and if I am saying that all the tangent vectors goes in the x direction, so what is fixed out here? Direction is fixed out, but the point of applications are different. You can observe the difference in the two images. Correct?
Yes, ma'am.
Okay, here a direction is not specified, but in the second case the direction is specified. What is the direction? All the vectors are allowed to go in the x direction only. Okay, just like our gravitational vector field, in which what we have been provided that all the vectors or all the object whatever you are going to put in they definitely go in the downward direction. Okay, in the very similar way I have to do it for y axis, or you can say it is instead of saying x-axis, so we can say u1 vector field. U1 means what? All the tangent vectors are going in the first direction, that is x-axis. And another one we can say it is u2 vector field, in which this is what your x-axis, y-axis and z-axis. So all the tangent vectors are going in the y direction. Correct? And the z1, that is u3, in which all the tangent vectors are going in the, so this is what x, y and z. So all the tangent vectors now are going in the z direction. Correct? Are you able to see what is the difference?
Yes, ma'am.
Okay, so simply it is the idea that instead of having any arbitrary direction of those tangent vector, we are going to fix out the direction. What is the direction now fixed out? Either it is x, y or z direction. Okay, so point of applications are different, but their direction vectors are the same. Okay, so here the first one we call it as u1 vector field, second is u2 and third one is u3. Okay, starting with the definition. What is the definition of a vector field? It is simply a collection of all the tangent vectors once at every point. But actually, this is not a definition. What is actual definition? It is a function defined on E3 space such that at every point P of E3 space there exists a one tangent vector. Okay, so this is what the image, at every point P you can find out one tangent vector. But if suppose directions are specified, that means suppose I am having the direction x-axis. अगर हमारे पास only x-axis direction है, so we say all the tangent vectors to go in only x direction, that is a u1 vector field, capital U1. And in general, we write V, W, this type of a notation for the vector field. And if it is a specific one, then we write it as a U1 vector field, U2 vector field, and U3 vector field. Understood this one?
Yes, ma'am.
Okay. So this type of vector field have been provided one specific name. U1P means what? 1, 0, 0 at a point P. That means all the tangent vectors are having a unit vector and they are going in the x direction, 1, 0, 0. U2P, we can say it is 0, 1, 0 at a point P. Because point of applications are different, no? At every point P, you have to find out one tangent vector. You can see here, at every point, you have to find out one tangent vector. So here also tangent vectors are there. Here also there, but they are going in the y direction. So U3P means what? At every point P, here it is 0, 0, 1 at a point P. So we are collecting unit tangent vector which are going in the direction of z-axis, that is 0, 0, 1 at a point P. So at every point P, we can have one tangent vector. Okay? Have you understood this one? If yes, let us go for the next one. That means whatever the tangent vectors we have seen, after tangent vector I have shown you that how to find out the addition of a tangent vectors, right? With the help of parallelogram law, we have found this. These are one vector, this is another vector, say PP and WP. Okay, so resultant vector, the P plus WP will lie in the diagonal, and this one is the opposite one because it has a opposite direction. Before going to this one, I want to ask you whether you remember the law of parallelogram. याद है क्या आपको parallelogram law क्या था?
Yes, ma'am.
हाँ, can
लॉ यूज करायचा मॅम तिथे.
yes. Law क्या था? Starting with the definition.
Starting with initial point of first vector and ending with end point of second vector.
Starting with the initial point of first vector to the end of endpoints of the second vector. Okay, so this is what Vp plus Wp. So how it is written, V plus W at a point P is nothing but Vp plus Wp. This we have seen in the last lecture. So this is what the vector addition and scalar multiplication, A Vp is equals to A times Vp. Now everything depends upon A. That means suppose we have this one is a tangent vector Vp. So if A is positive, it goes in this direction. If A is negative, it goes in the backward direction. And if A is 0, it goes here. Barabar? Now in the very similar way which we have done for a tangent vector, that is we have defined what is a vector addition and what is a scalar multiplication. So now let us do the same thing for a vector field. Okay, suppose V and W are the vector field and we have to find out what will be the effect, that is V capital V at a point P plus capital W at a point P. Let V and W be the vector field, then addition of the two vector field at a point P is defined by vector field at a point P, vector field W at a point P. Now here, instead of taking any scalar, as it is a vector field, so that's why instead of taking a scalar, we have taken a function f, and a vector field V at a point P will be evaluated as f of P and vector field evaluated at a point P. Later on, whenever you are going to solve the examples on this, you will understand how to how to evaluate a vector field V on a point P. Suppose we have been provided with one vector field and we have to evaluate on a point P. Point P क्या होगा? Point P we have taken from E3 space. Suppose P we have considered to be 1, 2 and 4 and vector field B is also given to you. So this vector field B we have to evaluate at that point 1, 2 and 4. Okay. So in this way I will show you later on while solving the example how these equations will be equal. Initially हमने जब define किया था tangent vector, so instead of taking the function itself we have taken the scalar a, but here as it is a vector field, so that's why instead of taking any scalar we have taken one function f. Okay, real valued function. So value of a real valued function evaluated at a point p काय असणार आहे?
रियल असेल ना.
Okay, suppose f is a real valued function, x square evaluated at a point p. Okay, value of f at a point p क्या होगा? X square, suppose p is a 1, 2, 4. What is the value of x here? 1. So 1 square it is equal to 1. So value of a function is equal to 1. So that is a scalar. So value of a function f, a real valued function evaluated at a point p of E3 space. Okay. Real valued function evaluated at a point p of E3 space. काय असणार आहे resultant? Scalar number असेल ना? Just like here. Suppose it is some function like x square into y evaluated at a point p. X square का value क्या होगा? 1 square. What is y? Y is 2. 2 into 1 काय असणार आहे? 2. Right? So this is also one scalar. Whatever the resultant we are getting here, it is 2 times the value of vector field evaluated at a point p. Have you understood this?
Yes, ma'am.
Yes, any student, if you have any doubt related to vector field, how the vector addition is defined, vector field addition and scalar multiplication to the vector field. Yes, everyone getting me what I told you? A real valued function defined, or we have to evaluate this on a point P of a E3 space. It will give you some scalar number. कुठलाही रिअल व्हॅल्यूड फंक्शन घ्या, z स्क्वेअर घ्या. z स्क्वेअर काय येणार आहे? z स्क्वेअरचा व्हॅल्यू 1 to 4 ला
16.
4 square, that is 16. So this is again a scalar. Okay. So this is what we have defined. What is a vector field? And first one is a vector addition on a vector field, and second one is a scalar multiplication. Okay. Now let us see one theorem related to these vector field which we seen just now. What are the spatial vector field we have studied is u1 at p, u2 at a point p and u3 at a point p. Okay, as initially from the classical mechanics lecture I told you that it is very important for us to have a Euclidean space, because at every point I can find out a Euclidean space. ऐसा define नहीं किया है कि origin is there in Delhi only or origin is there in the New York. So it will be very difficult for us to measure the distances from New York or Delhi or London, कोई तो बड़ा city जो भी होगा, ओके वहां से हमको डिस्टेंस मेजर करना पड़ता है ना. बट हियर व्हाट इज अ इम्पोर्टेंट प्रॉपर्टी, you can specify or you can draw E3 space at every point. Okay, so here if origin is here some with 0 0 0, right, and this is what your x-axis, y-axis and z-axis. Now what is given here, u1p, u2p, u3p means what? Suppose instead of having a origin, if I have a p here, right, so how you are going to find out what are these axes? यहाँ पे हम डायरेक्टली कह सकते हैं ना इसको 1 0 0 if it is unit. Here we can say 0 0 1 and here we can say 0 1 0. In the very similar way, what you can say, if I have shifted the origin from 0 0 0 to arbitrary point p, काय लिहू इथे x y z डायरेक्शन मध्ये?
p00.
Okay, p00. Yes, anyone else want to answer this?
मैम रिपीट करा ना.
Okay, so what I told you, instead of having the origin at 0 0 0, right, origin कहाँ पे हमारा 0 0 0, right? So if I am going in the x direction, what I write, assuming this to be unit 1, unit distance अगर हमने consider किया तो 1 0 0, और z का डायरेक्शन क्या होगा 0 0 1 and y का डायरेक्शन में क्या होगा 0 1 0, right? But if suppose I have shifted the origin to some another point p with the coordinates say p1, p2 and p3. Now can you tell me very similar way, यहाँ पे अगर मैंने origin shift किया है तो इन इस directions का जो vector है, what is the direction of these vector? क्या होगा वहाँ पे vector? In the direction of x-axis, y-axis and z-axis, which vector will lie?
Times 1 1 1.
Yes.
P of 1 1 1.
P of 1 1 1. Is it correct? Okay.
P1 1 plus P2 and P3.
P1 1 plus P2 and P3. हे कुठे लिहिणार वेक्टर है?
y-axis.
Okay, y-axis. P1 1 plus P2 and P3. Now can you explain how you found this one?
मॅम ऍडिशन केलं म्हणजे P1 P2 P3 हे एक वेक्टरचा आणि 0 1 आणि 0चा.
सो एक्चुअली ओरिजिन अगर है यहाँ पे तो यहाँ पे x एक्सिस में क्या आ गया 1 0 0. ओके, इंस्टेड ऑफ 0 0 वी हैव वन अनदर पॉइंट P2 एंड P3, राइट? सो x की डायरेक्शन में P2 और P3 फिक्स होगा, करेक्ट? आई एम राइटिंग फॉर दिस वन. एंड व्हाट विल बी द चेंज इन 1? यहाँ पे ऑलरेडी 1 है, so what I can write 1 plus P1. Is it okay? Okay, let me draw in. Suppose this is what your original one, and suppose here is one point P with the coordinates say P1, P2, P3, and this is what your origin. Okay, अगर हम x डायरेक्शन में यूनिट वेक्टर लेते हैं तो वो कैसे दिखेगा 1 0 0, y डायरेक्शन में 0 1 0, z डायरेक्शंस में 0 0 1. Okay, now if I want to find out one vector here in this direction, हमने origin को shift किया है point P पे, right? So here what you have to do is यहाँ पे अगर आप ऑब्जर्व करोगे तो 0 0 0 की जगह पे 1 0 0 आ गया, राइट. सो यहाँ पे 0 0 ये दोनों एज इट इज कैरी हुआ है, करेक्ट. So this P2 and P3 in this direction I have to carry as it is, P2 P3 as it is. So what is the change? यहाँ पे 1 है और यहाँ पे P1 है. So I have to add them, 1 plus P1, correct. In the very similar way here also you can do. Okay, यहाँ पे क्या fixed होगा? First two coordinates, right? Sorry, it should be 0 1 0 ना? नहीं, it is Z axis, no? So as it is a Z axis, so first two coordinates P1 and P2 are fixed out. What is the change in the third one? 1 is already there. And what is the change here? It is P3. 1 plus P3. Okay. So here also we can have, this is what in the Y direction P1 and P3 are fixed out. And what is the change? यहाँ पे already 1 है. So 1 plus P2. Okay. Are you getting me? How to shift the origin?
Yes, ma'am.
Okay. If you have a doubt for this one, you can ask. Yes. सगळे अटेंड करतायत ना लेक्चर का फक्त चालू करून ठेवून गेले? Should I call the presentee now? Ashwini Lange, Sanjana Aute,
Yes, ma'am.
Bhosle Purnima, Shraddha Chitte, Jadhav.
Present, ma'am. Yes, ma'am.
Chandigiri.
Present, ma'am.
कुलकर्णी ऐश्वर्या, काजल गौड़ी.
Yes, ma'am.
Yes, ma'am.
मेघा काड़े.
Yes, ma'am.
रितु मागे.
Yes, ma'am.
प्राजक्ता जामदार.
Yes, ma'am.
संदीप गर्गी. Absent. तेली शुभांगी.
Yes, ma'am.
सोनार श्वेतजा.
Present, ma'am.
जुबिया जमादार.
Yes, ma'am.
शिंदे विनीता.
Yes, ma'am.
Okay. It's okay. So have you understood how to find out the shift of origin? Simply you have to change some of the coordinate, that is जहाँ पे हमने 1 है वहाँ पे सिर्फ उस coordinate को 1 plus P1 करना है if it is in X direction, 1 plus P2 if it is in Y direction, and 1 plus P3 in the Z direction. All others will be as it is because यहाँ पे भी हमारा origin के 0 0 as it is carry किए ना हमने यहाँ पे. What about Y axis? 0 0. First and third as it is carry किए 1 यहाँ पे Y axis. Okay. So now these are the things which we have seen for the natural frame field. Now let us go for one theorem. What the theorem tells you, I will write the statement of the theorem and will prove. Any vector field V on E3 is uniquely expressed as any vector field capital V. So any vector field means what? You should know definition of a vector field capital V on E3 is uniquely expressed as uniquely expressed as V is equal to V1 U1 plus V2 U2 plus V3 U3. So what are this? V1, V2, V3 are real valued function on E3 evaluated at a point P. Real valued function on E3 evaluated at a point P of the E3 space. Or rather you can say V1, V2, V3 are the natural coordinate functions So we have been provided v1, v2, v3 are real valued function evaluated at a point P, and any vector field B, we have to say that this vector field B can be written in the linear combination of the natural frame field. What are natural frame field? U1, U2 and U3. What is U1? It is a natural frame field in which all the vectors in the x direction. U2 क्या होगा? All the vectors are going in the y direction. Z. U3 means what? All the vectors are going in the z direction. Is it okay? Have you understood what we want to prove and what is given to us? Yes, काय दिलेलं आहे थेरम मध्ये आणि काय प्रूव्ह करायचं आहे? Yes, it is easy or very difficult to find out what is given and what is our aim to prove. Okay, let me start with the proof. So what is given to us? We have been provided that any vector field. That means we have any vector field V is given to us. So how the vector field is defined? It is a function from E3 to union TP of a E3. Correct? This is what the definition of vector field P is a function defined on E3 space such that at every point P of a E3 space there exists a one tangent vector. Or simply you can say it is collection of all the tangent vector ones at every point of a E3 space. Okay? Here definition is given. What is the definition? It is a collection of all the tangent vector ones at every point. So if you are provided that one vector field is there, so you can use the definition of a vector field. Vector field V is a function on E3 such that it is having one tangent vector once at every point P of a E3 space. Okay, so I can use the definition such that we can say it assigns a tangent vector PP at every point P of E3 space. If the statement is correct, hello?
Yes, ma'am.
Okay, so what you have to do if we are in the vector field, let us again go back to the definition. What is there in the definition? At every point I have one tangent vector. So in the vector field में क्या है? सभी tangent vector ही है ना? It is simply a collection of all the tangent vector. And out of all those, if I go to this point, what I will get at this point? I will get one tangent vector. आप किसी भी point पे जाओ E3 में, आपको एक tangent vector मिलेगा. Is it okay? So if I go to each point P of a E3 space, I will get one tangent vector. So what I will do, suppose I will go to a point P right? If I go to a point P, then I will get a one tangent vector VP, V of P, and this V of P I can write it as V1 of P, V2 of P, V3 of P. Is it correct? Okay, what is P? P, we have been provided that it is a point in E3 space. So how the coordinates of P will look like? They are real number? Coordinates of a point P. Guys, not a coordinates of point P, they are real number. Because in the last lecture we have defined what is a x of P, y of P, z of P. आठवते का सगळ्यांना? What was the value of x of P? It is P1. What is the value of y of P? P2. What is the value of z of P? It is P3 if point P is given with the P1, P2 and P3. So what do you mean by x of P? It is x coordinate of a point P. If P is from E3 space, each and every coordinate is a real number. Okay. So out of all the vector field, if I go to one point, अगर मैं किसी एक point पे जाती हूँ तो वहां पे मुझे एक छोटा tangent vector मिलेगा. Correct? So what is P? P is only a one point. Now I can write this as this whatever we have P of P. We can write this one in the very similar way of P of P is equals to V1 at P 0 0. I can write like this plus second one 0 V2P 0 plus third one 0 0 V3 at a point P. Is it okay?
Yes, ma'am.
क्या किया है हमने? सिर्फ V1 V2 V3 को सेपरेट करके लिखा है, राइट? सो वेक्टर फील्ड V इवैल्यूएटेड एट अ पॉइंट P इज अ टेंजेंट वेक्टर. ओके, पूरा वेक्टर फील्ड में से हमें सिंपली एक पॉइंट पे जाना है. So what we get one tangent vector which is equal to, if I take V1P outside now, so what I get inside of this one 1 0 0 evaluated at a point P, correct? Plus if I take a V2 outside, V2 of P, so this will be 0 1 0 evaluated at a point P, correct? Plus V3 if I have taken outside, so what I remain 0 0 1 evaluated at a point P. So which is equal to, what is the value of a vector field V evaluated at a point P will go to a one tangent vector. Okay, पूरे वेक्टर फील्ड में से हमें सिंपली एक पॉइंट पे जाना है तो वहां पे आपको क्या मिलेगा? एक tangent vector, right? So V1 at a point P if I have taken outside, what is the value of this one, this and this? माहिती आहे का सगळ्यांना? U1 at point P आहे ना. U1 म्हणजे काय असेल? All the unit vector going in the x direction plus V2P as it is. What is 0 1 0? This is all the unit vector going in the y direction plus V3 of P as it is. Next, what is the resultant? This is what U3 at a point P because all the unit vector going in the z direction. Are you getting me? Any doubt for this one?
No, ma'am.
If not, let us now combine this point. So we can have V1 U1 evaluated at a point P plus V2 U2 evaluated at a point P because point P is common here, no? Plus V3 U3 evaluated at a point P. Now this point P we can take outside. This is what a tangent vector VP and here vector field capital V evaluated at a point P, which is equal to, now I can take point P outside, P1 U1 plus V2 U2 plus V3 u3 evaluated at point P. Now as point P is an arbitrary point, so we can take the resultant as V is equal to V1 u1 plus V2 u2 plus V3 u3. Okay, so hence we have a result that any vector field V can be written as a linear combination of a u1, u2 and u3. Okay, or in short, if you haven't understood this once again, so what I can say is I hope you have studied a basis R3 over R. So in that basis, definition of basis में क्या होता है? First it is linearly independent and second one is a span. So यहाँ में हमने सिर्फ spanning ही प्रूव किया है, right? So any vector from R3 space, suppose it is x, y, z vector. So I can write this x, y, z as x1, 0, 0 plus y, 0, 1, 0 plus z, 0, 0, 1. लिहू शकतो असं? With the help of a basis vector ना, ये basis vector ही है ना आपके. But here origin is fixed out, that is 0, 0, 0. But here in this differential geometry, origin is not fixed out. That's why we are writing it as u1p, u2p and u3p. Correct? Understood this one? समझते का differential geometry?
Yes, ma'am.
Okay. अगर कुछ प्रॉब्लम भी है तो आप क्या करो, एक वेक्टर ले लो 1 2 3 and then write down this 1 2 3 in the linear combinations of 1 0 0 0 1 0 and 0 0 1. अगर आपको लिखने आ गया तो मतलब आपको थ्योरम समझ में आ गया. ओके, हाउ यू विल राइट 1 outside 1 0 0 plus 2 outside 0 1 0 plus 3 outside 0 0 1. लिहू शकतो असं. स्पॅनिंग करना है आपको सिर्फ. स्पॅनिंग मीन्स व्हाट? एनी वेक्टर फ्रॉम R3 space can be written as a linear combination of 1 0 0 0 1 0 and 0 0 1. Okay, so if you're not having a doubt, let us stop the lecture. In the next lecture we will go for the examples of the vector field and the directional derivative. I hope you studied the directional derivative somewhere in your first semester. झाला होता? Yes, can anyone tell me what is a directional derivative? Yes, any idea about the directional derivative, ordinary derivative, partial derivative, why they have introduced? Derivative means what? Rate of change, ordinary. Then we go for the classification of them: linear, non-linear, homogeneous, non-homogeneous type of differential equations. Then we go for partial derivative. Why there is need to introduce a partial derivative? If more than one independent variable is there, right? What is the definition of a differential equation? Yes, can you define differential equation? Yes, in the next lecture we have to go for directional derivative. For that we should know what is ordinary derivative, partial derivative. Then only we can go for the directional derivative, no? कधी अभ्यास करणार आहे बेसिकचा? हाँ. These are the points necessary for PG post graduation in mathematics. This is what a degree you are getting. मास्टर ऑफ मैथमेटिक्स. अगर आपको नीड ही पता नहीं है पार्शियल डेरिवेटिव क्यों डिफाइन किया, डायरेक्शनल डेरिवेटिव क्यों डिफाइन किया, सो व्हाट इज द यूज ऑफ दैट मास्टर ऑफ साइंस. आपको आता है बट आप लोग एक्सप्रेस नहीं कर पाते हो, राइट? So you should express it, no? Whenever the question is asked, if suppose you are facing the interview, अगर आपको आता है आपने बताया नहीं, so how they will understand that you know it?
The equation in which derivative term of derivative exists, it is called differential equation.
Derivative terms is existing. Okay. Or more elaborately, we can say an equation in which the derivative of a dependent variable with respect to independent variable is given. With then we can say it is a differential equation. And why there is need to introduce the partial derivative? If suppose your function is not in the form of y is equal to f of x, suppose it is z is equal to some f of xy. If it is having more than one independent variable, okay? If it is having more than one independent variable, then how to define a derivative? That was a problem for them. So they have evaluated this and the partial derivative comes. But again, there are some drawbacks in the partial derivative. One question is there whether the existence of partial derivative, whether it implies that it will be continuous function, because for derivative we say that if a function
No, ma'am.
is derivable we can say it is continuous. Derivative implies continuity, but reverse is not possible. Whether the same thing is there for partial derivative?
No, ma'am.
No. I hope you are having the example for this counter example that in which a partial derivative exists but your function is not a continuous function. Okay. So there are some drawbacks in your partial derivative, so that we have introduces the concept of the directional derivative. Okay. So if you're not having doubt for this lecture, let us end the lecture. In the next lecture, we will go for some of the examples of the vector field, then actually how to evaluate the vector field. Okay. And then we will go for the definition of a directional derivative. Okay. Thank you. You can leave the meeting.